Hi, everyone, and thank you for joining us today. We have an amazing topic to talk about today, Agentic AI, but we'll give everybody one more minute and get started in about a minute. So hang tight, we're starting very soon. Okay, well, I think we can get started.
I'm ready if you are.
Great. So, again, thank you everybody for joining us today. In today's webinar, we'll dive into an amazing potential of Agentic AI. We'll see what this is and how it can help you personally and in a business use case. And we'll talk about why integrating your company's data into LLM agents is the key to making it all work. So my name is Iris Zarecki, and I'm Product Marketing Director here at K2View. With me today is Yuval Perlov, our CTO. Great to have you with us today, Yuval.
So happy to be here with you as well. Thank you.
Great. So let's get started. Our agenda for today. We'll talk about what is agentic AI and why is it such a big deal? Why should you care? And give you some examples. Then we'll cover why enterprise data is so important to being successful here. And we'll discuss the new emerging use case, which we call data integration into LLM agents. And Yuval will actually demonstrate how and what this looks like inside the K2View platform. And we'll end with a Q&A, as always. So just for the Q&A session, which will be at the end of this session, please use the questions tab below the screen to submit your questions, and we will address them at the very end. But feel free to start submitting your questions right now, and we'll take them at the end. So with that, let's get started. So agentic AI, everyone is talking about it. It's the biggest buzzword ever. Gartner just called it the number one top strategic technology trend for 2025. NVIDIA CEO is talking about it. Salesforce are talking about it all the time. You see here a quote from Mark Benioff, Agentic AI is the new labor model, new productivity model, and new economic model. So it's brand new. It's very exciting. And the question is, what is it and why should you care? So I found two interesting definitions of what AI agents are all about. I like the one from Gartner on the left-hand side, so let's start with that. AI agents are autonomous or semi-autonomous software entities that use AI techniques to perceive, make decisions, take action, and achieve goals. So that's the Gartner definition. AWS is actually talking about something very similar. They mention independent, which is to me very similar to autonomous. They talk about setting a goal, collecting data, taking action. And I think from both of these definitions and many others that you can find online, what makes AI agents unique and new and exciting is these four things that you have on the right-hand side. Number one, they're independent. They can do things uh, in a process, but with some supervision, but they can do a lot of things independently. And we'll show you some examples. They can take actions. That's the exciting thing. They can get things done with or without human supervision. They definitely need to collect data, whether it's data from the internet or data from the company's website or internal knowledge bases, or maybe it's specific data about you as a customer. They can collect data in order to make those decisions. The decisions are based on data. And There's a process. It's not a one-off like we are used to with ChatGPT, for example. It's not I'm asking a question and getting an answer and that's it, I'm done. It's a process, maybe even a long process, maybe an ongoing process with some human points of supervision in the middle, but there is a process. So there's a lot of automation and orchestration that is part of what AI agents are all about. Anything to add, Yuval?
Yes, I think what makes this technology maybe unique in software architectures is that it's the first time that all these attributes combined create a system where you can expect it to solve problems you haven't anticipated during development time. And this is a unique scenario. So in the past, developing a software system involved creating test cases and laying out exactly how it can solve the problems, even if it's autonomous, even if it's independent, it would still adhere to the use cases it was programmed to do. And this is the first time we have a system where we expect it to deal with issues we haven't anticipated and haven't planned for. And this makes it a very unique and also a challenging proposition.
Right. So unexpected problems, right? Interesting. Let's look at some examples, and I think these examples will make you very excited as well. Let's first look at some personal examples. So think about the example at the top. I want the AI agents to book a flight for me to Italy between these dates and for less than $500. Now, what happens behind the scenes is again a process. The process of finding the relevant flights, according to my preferences, according to the price that I decided, and then maybe even booking it for me with my credit card. So it's a process, and at the end of the process, you even take action. Another example is an autonomous AI shopping agent, right? For me as a woman, it's a dream. Uh, some shopping assistant that will know all of my preferences with regard to clothes, shoes, colors, sizes, whatever, will review hundreds of websites, including specific websites that I tend to buy from, understand when there's a good reviews and bad reviews about products, new products, old products, and also when there's a sale and maybe my favorite product is now sold for 20% less. And then again, with human supervision, notify me about those sales or products that I'm very interested in, or maybe even buy them for me because he knows I like these shoes and he knows this price is very good. So let's go ahead and buy it again using my credit card. So that's an exciting example, personal example. Maybe the last one is not so exciting. Returning my shoes is actually a chore, that something that I need to get done, not something exciting. But it can also be done by AI agents. So the agent can search for my receipt. It can locate my order number in my email, fill in the return form on the relevant website, and even schedule a pickup to get the shoes back from me. So this is again a combination of physical and digital world. An AI agent system can do all of that for me. And this specific example was actually demonstrated by Google CEO in their last event in 2024. So all of these are personal examples, very exciting. Imagine what else we can do with these kind of technologies. And like Yuval said, it's unpredictable problems. So not just a process. But when we take it to the commercial world, it's even more exciting. So here are two examples. The first one is from worlds of HR. So think about I'm trying to look for talent. I'm trying to search for talents that match these job requisitions for a senior software. So what can the AI agent do for me in this scenario? They can, first of all, learn about the company's preferences or the recruiter preferences. What is the location, pay range, specific skills I'm looking for. And next, the agentic framework can look for, scan LinkedIn, get a lot of data about the people that can fit the job and have qualified skills, and also internal candidates that might be able to might have those skills that I'm looking for. Then the agent will create a short list, set up some interviews, again with human supervision or not, analyze those interviews for body language or whatever, um, interview them, look at backgrounds, look at references, and create a list of sufficient candidates, good candidates for the recruiter to choose between them. So that's again an amazing process, an ongoing process that can be applied for every job that I have. And the recruiter can get a lot of help with maybe the automatic tasks that must be done as part of this process. Let's look at another example, this time in customer service. So today, when we think about using Gen AI in customer service, when we think about your typical chatbot, it's pretty basic. It's very rule-based. Like Yuval mentioned before, it knows how to answer very structured problems that I've defined in advance. It's not able to address any question that the user might have, definitely not in natural language, right? But we're already seeing with many of our customers providing what they call a virtual assistant, a virtual rep assistant that allows the rep to ask some questions in natural language about a specific customer and be able to answer much faster, helping KPIs, improving KPIs like short handle time and higher customer satisfaction, and of course, quicker ramp up time for the rep, the call center rep. And next, we see customers exposing this directly to the customer once they get some confidence, and allowing the customer to ask the questions directly, communicate directly with the chatbot. And again, there could be a human in the loop or not, but once we gain trust, we allow the customer to communicate directly. And the vision, which you see on the right-hand side, is to have an autonomous set of agents which will look after customer satisfaction, and they can be proactive. They can predict if something is going to upset the customer and deal with it even before the customer is unhappy. They can have some goal-oriented actions. If my call center ratings is going down, do something about it. Proactively approach some customers that are unhappy. Make some decisions based on the customer service. So it's about making data-driven decisions. It's about scalability because the agents don't require me to make my call center bigger, but they can still handle a large number of customers and hopefully support growth that way.
If I can chime in. So first, again, I think customer service is maybe the best place to deal with the unexpected issues, just because people surprise us every time, and they're not even working for us, so they're not bound by the company processes. They can just ask anything and surprise us in continuing ways. What we see today with our customers, at least, that there's somewhere between rep assist and customer assist. So we definitely see our customers already using rep assist with Gen AI. So when they open the CRM, they already have the suggestion and what's going on with the user, and they can interact with the systems in a very human like interface. And we also see some initial tests of customer assist. Again, the aim is, of course, to gain confidence and then move forward with these technologies.
Interesting. Great, thank you. So exactly like you said, we see that most customers are still here and didn't get to the autonomous agents phase yet. The question is why? And I think there's a gap. Oops, I'm sorry. There's a little bit of a gap. And Gartner was talking about it in a recent article that you see here on the right. The agents today are still very static. They're not adaptive, not adapting to the situation. They're still reactive and not yet being proactive. And they can deal with simple tasks versus complex tasks that we want them to deal with. So there's still a gap here, which we need to work on. And what Gartner is saying is that AI agents will need to have, first of all, data, AI-ready data. The data that you have today is not good enough for AI agents to consume and make some decisions based on it. Also, they're talking about AI-ready process. And the processes within the company, whether it's processes of the customer service, the call center, or processes in HR, they're not yet ready to be consumed or replicated by AI agent. And also guardrails, security and privacy. It's very important to make sure that any data you expose to the AI agents is kept private and secured at all times. So a lot of things to still make sure happen.
And I want to add to that, Iris, that the guardrails here, it looks like an afterthought, but in a sense, it's very central to the architecture, because the thing about this flexibility and the thing about AI agents and LLMs in general, where they will always answer, is that you get a very good chance for a positive outcome, but you have to guard yourself against negative outcomes. And on every layer of these additions, we need guardrails. So yes, we have the LLM guardrails, the standard ones that make sure the text conforms to standards and to the tone that the enterprise wants to take. But we also need to guardrail the data layer to make sure we can't leak data, so we don't expose the wrong data in the first place to the LLM. So even if our language guardrail fails, that doesn't matter because we haven't exposed the wrong data. And same goes to the processes, not to expose the wrong processes at the wrong time, to guard from mistakes. LLMs today get a very high percentage of things right, but it's never 100%. So the guardrails are essential throughout the technology stack.
Right. Thank you, Ivan. And this is a great article that SiliconANGLE published just before the holidays. It's called The Yellow Brick Road to Agentic AI. I really like it. And that's why you have it in the attachments tab for this webinar. And the article talks about the road to Agentic AI, obviously, and suggests that Agentic AI cannot succeed without a strong data foundation. And what does it mean? It means that you're almost trying to break silos or disrupt an ecosystem or an architecture of 50 years of data and application silos. And it's not something that you can do in a day. So it does take time to break down the silos, definitely between data sets and applications, and your data, your customer data specifically, is all over the place. So just putting it in a big data lake does not mean that you broke down the silos, and is not enough to really get on the road to successful agentic AI. And this is exactly where K2View comes into the picture. We offer a new way to organize the data, a new way to consume the data in the dynamic agents. So regardless of where the data is today, whether it's in your CRM, in your customer support systems, in your data lake, we create a semantic layer on top of your data around a business entity like a customer, very relevant, for example, for the customer support example we looked at before. This way, the semantic layer can have all the information about the customer, whether it's his invoices, his status, anything and everything about the customer is available in the semantic layer. And on top of that, we use the dynamic data agents to provide that data to the GenAI applications. So when Yuval talked about unpredictable questions, think about the customer support example we looked at before. We don't have to predict the questions anymore because the dynamic data agents can answer pretty much any question about the customer because they have access to any data about this customer. So this is very exciting, and the result is secure, low cost, and quick solution to conversational GenAI applications, a solution that provides the customer data that they need in accordance to everything we talked about before, guardrails around the data, making sure it's always secured and private. The data is always fresh and up to date. The response time is conversational and appropriate for chatbot scenarios. You don't have to write agents for every potential questions. You can use the dynamic data agents to answer any question about a customer. And we can, any prompt to SQL, the user can ask whatever they want, and the dynamic agents will translate that to the relevant questions. So that was a mouthful, but Yuval, maybe let's drill down a little bit.
Sure. So this is a very, very high level architecture or flow example. So on the left-hand side, we see things that might come into the system, prompts. So it can be an end user asking a question, such as my internet is not working. It can be initiated by an agent saying compare compare the last three customers' last invoices. So it's in the third party, but it's all in the third party, but it's also about the customer. And it can also be an automated process. Ask to predict why the user is calling now, or show me a profile and status of the customer to initiate a conversation. All of these prompts go into the dynamic agent where it creates goals and instructions based on these. If there is a conversation history, a context to them, it will pick them up automatically. And it brings in the data product metadata, which is basically our semantic layer that is always there. So with K2View, for many years now, we've been dealing with modeling business entities and extracting them from the various databases and source systems and systems of record of truth in the organization. And we can assemble a micro database that represents a specific customers within a sub-second performance. So upfront, we model what is a customer, how is it laid out on the various systems, and we can extract it a sub-second performance to bring fresh data and expose it to the LLM. And we do two things here. First, we bring the data, but we also add a semantic layer to it where it's well documented and explained. And we also have an implicit guardrail because we only brought that one customer. We're not exposing the LLM to the entire database, and we're not exposing it to a very limited set of APIs. So on one hand, we're showing it a lot of relevant data to give it a lot of flexibility. On the other hand, we're not overexposing to show and letting the LLM take a wrong turn and hit the wrong data that it's not supposed to. So just the right data, not too little, not too late, and always fresh. And then we analyze it, and we'll see that in the demo how it works. We let the LLM analyze the data, analyze the question, craft queries to bring data from the microdatabase, and then with all this context, we ask the LLM, is there more data needed? If yes, it goes back to the microdatabase and fetches some more data. If the microdatabase is small enough, it can fetch the entire microdatabase, of course. And then it arrives at a decision whether we have all the answer or not. If we do, it crafts a nice answer for the end user. So this is a very high level basic flow. Of course, the details are a bit more. There are some more details to it, but it shows the overarching technique of this dynamic data agent together with the microdatabase that's always updated, always fresh, and used to manufacture a response to what could potentially be an unexpected question. Another thing worth mentioning here, if we're talking about guardrails, if we don't want to expose actual PII data to the LLM, we have the way to mask the data from the microdatabase to the LLM, and then turn it back to real data when we show the response to the end user. So we even have this guardrail that makes sure the LLM itself is not overexposed to private data. Does that make sense?
Yes. Just tells me how important data is in this scenario. But you know what, Yuval? Let's see it in action.
All right.
I think this will make it much easier to understand. And we'll show you guys a quick demo. In the demo, we're looking at a company, a telco company called Elite Telco. And one of the customers, David Smith in this example, is calling us and asking why his own home internet is not working. And Yuval will show you everything that happens behind the scenes.
Okay, let's go. Iris, can you see my screen?
Yes.
All right, great. So we'll start with a simple question. We've seen it before in the presentation. My home internet is not working. So I'm David Smith. So Elite talks to me, of course, in the first person. And this is two things. There's an active service outage in my area, and there are outstanding invoices I haven't paid. And of course, this is taking information from from the enterprise data. If I type this to a ChatGPT, of course, it wouldn't know these things. And it would give me a very generic answer of how I can troubleshoot my home internet. Here, it's based on enterprise data that's taken from the microdatabase that represents one David Smith. Of course, the next question would be in the context of the entire conversation. So there's a state to this conversation and memory. So I can ask a very cryptic question otherwise, just invoices. But of course, within the context, I get the list of invoices I haven't paid. So This is a very, of course, a quick demo, so I want to dive in. So we're going to leave this conversation at this and dive in to see what really happened behind the scenes. So I'm clicking here the trace. Of course, this is not available to the actual end user. And we're getting a glimpse behind the scenes of what happens. So in actuality, there's three parties to this conversation. There's the end user, the LLM, and also the agent framework or the agentic framework that has this back and forth with the LLM until we can get a good answer for the end user. So we start out the conversation with a very general set of rules, some rudimentary prompt engineering. We tell it what its role in life is and what situation this particular agent is in. But then we do something interesting. We show the LLM the schema that represents the microdatabase. We chose here a standard SQL because SQL is well known to LLMs. They're pretty well trained with that. But if you see, it's a well annotated schema. It's not just the create tables, it's everything we know about this semantic layer and want the LLM to be aware of, such as fields and possible values and their meanings. Again, LLMs can glimpse a lot just from the names if we have good names, but we added a lot of information here to make that to make it available. And then we take a business problem and we ask the LLM to manufacture a query. So here it manufactured a query to get all the information of the devices and data we know about the user. And I'm going to scroll down a bit. We run the SQL. So the agent framework has decided to run this SQL that we got. Again, we only have access to David Smith's data. So if this SQL for some reason was erroneous or too wide, that's not the end of the world. We're still within the context of the database that only represents David Smith. We worry less about indexing. We worry less about data containment. And we ask the LLM to look at this data and give us some insights. So we get some insight. The gathered data indicates that the customer, David Smith, has multiple invoices and there's an active service outage. And this is the information it was able to glimpse from this query result. And I'm going to scroll down a bit here. We then ask the AI Data Fusion to address the customer question, giving all the data we gathered so far in the context. So the LLM has access to everything that this chat represents. And after we exposed all this information, we told him about Elite Telco, and we gave him the information about all the information that results from the queries. We ask the agent the agent asks the LLM to reflect if there is enough information, or do you want more data from the database? Given the question, my home internet is not working. And now the LLM says, I have all the data I need, right? Because we already gathered all this data. We brought it from the microdatabase, and we had this, we have all this information in context. And then we ask, again, the AI Data Fusion, the agent framework asks the LLM to craft an answer. And this is the first answer we see. So this is right here. Hello, David. I see that there's an active service outage. And then David says, invoices. And now the whole process repeats again, because I asked about data that's already available in the conversation context. This time when I asked, do you have all the data? It answers true, which in this case means, yes, I have all the data. And and then we ask it to craft the answer, and we get the next answer. And if I ask here, if I just say here, thank you, I'll take care of that. Then we see here that this time the answer is 4 because customer has finished the conversation, right? So we know how to go into a different direction. So we have here a few situations where we have all the information we need. 2, we need more data from the database, and then we have this very flexible query generation agent. We might need more data from the customer, or customer signed off. We can even ask for a chat summary at the end and ask the LLM to tell us what happened so far. So
Yuval,
whether it's a positive outcome. Yes, Iris.
we talked about taking action. Can the LLM also suggest to help the customer pay the bill?
Right. So in this case, because we wanted to simplify the demo, we didn't do that, and we're not a real elite telco elite company, elite telco company. So we just sent the customer to a fake portal to pay the payment, to make the payment. But of course, we can further introduce new tools and new capabilities into the agent, which would let it make payment. There is a question of a big question around PCI compliance and whether it's okay to send payment information over to LLMs. So I'm going to put that aside. Maybe you need an on-premise LLM. That makes it a bit more complex. And it might be in the short term a better solution to just send the user to a link to pay to make the payment. But of course, theoretically, it can easily gather information and send it outwards to APIs. So definitely possible.
Thank you.
I want to maybe show how a glimpse into the modeling tool we use. So what you see here is our K2 Studio. It's the Fabrics developer application. It was used to develop everything we just demoed, both the customer layer as the data layer, the microdatabase, the agentic AI on top of that, and even the UI was built, the user interface supporting this was also built and run within our system. So it's a very general purpose studio, taking us all the way from Java web development at the very core, all the way up to this two modeling tools that let you create a business entity, a microdatabase, or this agentic framework. Everything resides in one place. Again, real agents might be a bit more complex than what we're showing here, because it's a bit, we wanted to showcase a very simple use case to make it more understandable, but the principle here stands. We start with the initial state where we define the persona, the company, the steps we want to support. So this is very prepared in advance. This is for a new conversation. If it's an existing conversation, we just extract it from the database. We ask the agent to reflect whether it has enough information. We then branch out either to bring the data, and this is maybe our strongest agent. There's an agent hierarchy here to craft the SQL and extract the data. If the data is ready, it's a lot more straightforward. Prompt the user for more, again, a different crafting of a question, and a thank you and signing off. Whatever the branch is, we then append it to the conversation. We invoke the LLM again. We can even see it in action here.
So this is where we define the process, the automation.
So for now, let's fake a payment. We have here a fake payment
Okay.
backdoor just for the purpose of the demo. So I made the payment, and now I can ask about what is the ETA of my outage. And regardless of the answer, what I wanted to show is that I can see the data overlaid on this nice modeling UI. So I see here what is my outage. I can see the whole conversation that happened so far. I can even try it out and debug it within this UI. If I'm not happy with the results, I can make changes here and see what would happen if I change the prompt a bit. And this way I can build my agents and debug them. Um, in our list of capabilities, we can even introduce new agents and tools on the fly. So an agent can decide to use other agents based on the questions. We can give the agent access to knowledge databases to augment enterprise data with enterprise knowledge or with document stores, etc. And all of that to then bring all the data to the context and craft an answer to the user. If we want to take a glimpse into our modeling tool that's also here, so I'm going into customer, and here we see the customer model we're using. Again, this is the actual microdatabase that's available to our LLM. A bit simplified, of course, for the purpose of the demo. And behind the scenes, this microdatabase gets populated automatically from the various source systems on the fly, just on time, with everything needed to answer queries coming in from the LLM. And again, data can be cached. This is also a caching layer, so we remove a lot of stress from source systems. It's a very robust integration tool. We can query data just in time. We can query data in batches at off hours. Data can be pushed at us from various push APIs and Kafka or buses, such as a Kafka bus. So an extremely robust integration platform, exposing data just in time, on demand, in a certain scope to the LLM, and giving the LLM the freedom to utilize this data to craft answers to our customer, to our incoming question from the customer. And again, this is just one use case. Of course, we could use this set of tools to model any other use cases, whether it's a different data layer or a different interaction model. It's just reusing these same tools for other purposes.
Amazing.
That's it for my demo.
Thank you, Ivan. This was really exciting. Let me just go back to the slides. And we're nearing the end of our session today. So we're arrived at the Q&A. So for the Q&A session, I want to remind everyone to submit your questions using the questions tab below the screen so that we can see them and answer them. I see that we already have some questions from the audience, Yuval. That's great.
Yes, I think one that I would like to
Just
start.
one more thing before we jump to the questions. I just want to remind everyone that you will be getting a recording of this session probably within the next 24 hours. And you also have very interesting attachments here. The slides from today are in the attachment tabs. And also this Yellow Brick Road article from SiliconANGLE. And last but not least, if you want to see a full demo of what Yuval just showed us a glimpse, please answer the poll question and we will be in touch with you to see a full demo. So with that, Yuval, let's jump to the questions.
Yes. So the first question, actually, there's a few here revolving around that, is around our deployment model. How do you deploy our Fabric solution? So we are extremely flexible in several dimensions. We run on. We started out as a VM company, so we can run on VMs, on premise, old school, just deploy the processes and run them on premise. We can run on cloud native technologies within the customer's VPCs. So you can take our whole technology stack and deploy it on your cloud projects. And we support all three major clouds: Azure, GCP, and
AWS.
AWS. And we also can host the whole thing and give it as a service from our cloud. So we have this whole range of capabilities. And we also have a strong abstraction layer to the LLMs. So wherever you decide to run your Fabric instance, whether it's our cloud, your cloud, or on-premise, you can then from that access any LLM out there. And again, we support all the major LLMs. So it can be Gemini, AWS Bedrock, or Azure OpenAI, sorry, it can be OpenAI or Anthropic directly. And it, of course, we also support Olama and Mistral for on-premise deployments. And this gives you maybe the best privacy. There's a lot of heavy lifting that goes into that. You have to get the hardware, but you get the best privacy. We can also work in hybrid models, and that's also very interesting. You can have an on-premise or on-tenant local LLM where you have complete control, and you can use that LLM to mask data before you ship it to a cloud LLM to make sure you get privacy. So your heavy lifting is done by an LLM that's out of your full control, but you make sure data is fully masked before shipping it out using a local lower grade LLM and one that's cheaper to operate. Of course, you can mask data just by replacing tokens. We also support that. But the user can type in a PII. You can have misspellings with PII and not be able to replace them. So this added layer of a local LLM is a very strong combination. So everything on premise, everything on cloud, and then hybrid models in between.
And let me add to that question. Does the customer have flexibility to choose the LLM of his choice?
Yes. Just like you can connect to any database where the actual data resides, or the API of your choice where you fetch the data, in that sense, we treat LLMs the same way, right? We have this abstraction layer. We connect to the LLM of your choice, and you get to decide which one it is. What is interesting is that we can even combine LLMs for different purposes. Some LLMs are very fast and cheap. Some take a long time to answer, but give fuller and better results. And we can combine for different agents, different LLMs based on the needs.
Let's take another question, Yuval. The question is the K2B product a RAG framework?
So I think there's two interpretations to the word RAG here. One is, in a very general sense, fetch data from outside the LLM. So in that sense, yes, we augment the data using additional data that is outside the training of the LLM. And many times when people say RAG, they mean vector embedding or vector indexing of the data. And yes, we support that, but that is not our main technique for enterprise data. And the reason is that if you look at tabular data, relational data, masses of data that's available in an enterprise and siloed out in different systems, it's these techniques of using vector embedding do not work. They do not update quickly enough. They're very costly to update. They don't bring enough relevant data when it comes to tabular data. And we do use RAG when we need to augment it with knowledge and unstructured data, but structured data behaves differently. And we find that this technique that we just showed is much better and a much better fit. So yes, RAG in the very general sense, not RAG in the sense of vector embedding.
Thank you.
I see here another interesting question about how does the microdatabase get its data? So when we look at the microdatabase, we have one virtual relational database that represents a customer, and we have millions of them if we have millions of customers. When they're in use, they're hot and they're in memory. When they're not used, they're just sent somewhere to a blob store or even discarded completely. And the data does come on the fly just for the data queried by the agent. So when the agent makes the query, it doesn't know that it's not working with a real database, right? It's not fully aware. It's just got a SQL schema and creates a SQL. But when we take it, we analyze the SQL, we find out which data points are needed, we understand in advance the modeling of how the customer sits on the various enterprise data, and we fetch just the data we need to refresh the data that we already have in the database. So if we discarded the entire data set before for this customer, we'll fetch, and let's say the LLM asked for all the invoices, select, maybe not all the invoices, select amount from invoices, just wants the amounts. So we know how to look at this query, we know where this data resides in the various applications, and we fetch just that data set. The next time we will get this query, we will check if the data we have is fresh enough. So let's say invoices update once a month. So we see that our last invoice is from the last 5 days. We don't even query the source system. If we don't have data from the last 30 days, or the freshness is configured differently, we would go and fetch the remaining invoices that from that we need that are not stored in our database. So this whole mechanism is set up to reduce considerably the amount of stress on the source systems, and act as a guardrail that only takes the relevant data for this business entity and does not have the risk of overexposing, for instance, invoices that belong to other customers.
Interesting.
Yeah.
Thank you. You mentioned guardrails. So how can you be sure that the data is not exposed to the LLM and used in other places? How can you make sure those guardrails are actually working and the data is kept private and secured?
Yeah. So again, I'll touch on the key points that we went over. First is querying, understanding the customer model or the business entity model upfront. And of course, we have a lot of tools. We have a catalog discovery tool that goes and looks at the various systems. We have LLMs that help us understand the relations between the various systems and create this microdatabase. After we created a microdatabase and tested that it only fetches data to a specific customer, we are assured that we don't overexpose. We don't underexpose either, because we were showing the entire data set of that customer to the LLM. We're not showing it just a few tools and handicap it in that way. In addition, we have this masking ability where we take the PII and we can mask it before we send it to the LLM. And these two techniques combined offer us a very robust security and privacy layer between our enterprise data and the and the LLM. If we look at other techniques that are out there, for instance, exposing APIs, tools, exposing the entire database, which is kind of risky, this stands out as a very good way to do that, because we don't have to look at every API out there and make sure it's not overexposed. We start with a layer that's taking care of that, and only then using that as the foundation for LLM applications. So I think regardless of the underlying technologies, you need that layer that creates this semantic protection around your data, and not figure it out for every API out there and for every tool you're exposing to the LLM.
Got it. Thank you. Yuval, I think we have time for like one more question. Do you want to pick it?
Yeah, so maybe the basic one I see here is how does the agentic AI deal with hallucinations? So I think the interesting thing about LLMs is that they always give an answer, right? This is what they're good for.
Program to do.
It's seldom you will find an LLM that just says, "I don't know." They know, because that's what they do, and they give an answer, and I think and this is what enables dealing with unexpected questions, right? We don't have to program everything in advance and find out every eventuality. It just works with the data it has to craft an answer. The flip side of that is hallucinations, right? If it doesn't have a good answer, it might hallucinate one. And of course, there are guardrails and standard techniques in place to make sure to minimize that effect. But the whole idea of grounding LLM with enterprise data, with the microdatabase, and asking the LLM to focus on that, right? To make sure its answer comes from the data and not from general knowledge it has accumulated, and makes this a very good guardrail for hallucinations, right? And again, nothing is 100%, and of course you need a validation platform, which we haven't discussed a lot, but we do have this validation platform, which is a very robust tool to deal with all this with the chaotic nature of data agents. So strong validation platform to do regressions, to bring entropy into the system and test in advance as many cases as you can is essential. But the agentic framework that looks at the data that is grounded by the data agents, plus this validation framework to make sure you're on the right path, together they give you a lot of power against the hallucinations.
Great. Thank you very much, Yuval, and thank you everybody for joining us today.
I think it's important. I see we have a few more questions we haven't covered. We will cover them maybe by private emails.
Yes, absolutely.
Yeah.
So thank you again, everyone, for joining us today, and we hope to see you in our next webinar as well. Thank you.
Thank you. See you.